In the second step, the attacker will use a browser feature called the anchor scrolling that make a page automatically scroll to a specific ID when adding it as a hashtag in the URL. Here, in this example, every email is associated to a specific ID. For example, the first one from Jocelyn is associated to the ID checkbox 29. So if I add this ID as an hashtag in the URL, automatically the page is going to scroll like this. Bursztein showed that in the scrolling attack you can actually read from the outside frame if the targeted website scrolled or not, breaking at this point the same origin policy, because you can actually know if in the framed website some ID are present or not. We use this idea to steal private data from users, making binary tests of specific IDs. In the following demo, let me show you how we can actually conduct an attack against the mobile version of Yahoo Mail. As you can see here, the victim inbox contains at least one email from me. So if I search for my email, the page returned will contain the checkbox 29 ID. However, if I search from a non-existing sender, the search will be empty, so the checkbox 29 ID will not present and the page will not scroll. We use this binary test to know if the victim inbox contains email from specific senders. As you can see here, we know that the victim didn't receive any email from Elie, but received an email from me. This is a very serious security breach because it allows an attacker to know if a victim have an account on a specific bank or other drugs from a specific website. To prevent this kind of attacks called framing attacks, clickjacking and scrolling attack, most websites use frame busting defense. Frame busting is a defense that makes automatically a framed page come on the top of the page. However, Facebook have a slightly different approach to prevent clickjacking. When framed, Facebook displays a huge dark div on the top of the page, preventing the user from interacting with the Facebook content, but he is still able to see his information. When clicking on this dark div, automatically the page frame busts. This defense is useful against clickjacking. However, it will not prevent us from scrolling to specific IDs. We will use specific elements on different pages to know if, in the following demo, we'll show you how we can know using specific elements if the victim is logged on Facebook or not, who he is, and who are his friends. Actually, in the following demo, we use a non-existing ID. That makes we know if the user is logged or not. For example, looking for the registration ID, which only is displayed on the login page. On the left side of this demo is what the framing attack return, and on the right, what really happened under the hood. Here, you can see that we know that the user is logged on Facebook because the framed page didn't scroll. On the second point here, we are looking for a specific ID to know who is the victim. And as you can see, the page scrolls, so we know that this is not the good ID. This is not the logged user. But here, the page didn't scroll, so we know that Elie is logged on Facebook. We use a third specific ID to know who is his friends. So here the page scrolls, so we know that this cute girl is not his friend. And for the last test here, you will see that the page will not scroll, showing that we are friends on Facebook. To prevent this attack, Facebook updated the profile yesterday, and now they are not displaying anymore any content, any information about the profile. They just show a little picture like this. For the last part of this talk, I will let Elie conclude.
Thanks. So for the last part of the talk, I'm going to, which is probably my favorite one, we're going to discuss Tapjacking, which is clickjacking on steroids for our smartphone. As it has been said again and again, during the Black Hat, smartphone have a huge rise, a lot of Android phone around it, a lot of iPhone. How many of you have an Android or iPhone? Everyone. Ah, good. For this time, I have a lot of people raising their hand. And this has two main consequences, I guess. The first one is my iPhone is not working anymore because AT&T has not enough bandwidth. That's the first consequences. The second one is many popular websites has rolled out a version of the website, a mobile version, to be able to enable users who have smartphone to access it. And we found out that at least 53% of the 500 most visited websites have a mobile version. And you might not realize it, but the browser you have in this smartphone is fundamentally different from the browser you have on the desktop counterpart because of usability. The screen is so small that they had to make choices which are actually against security. The main thing you have, which is you don't have anymore a Chrome which is there all the time. You know, the Chrome is a part of the browser on the top that we trust to put security indicator on the top of it, such as the URL bar or whether it's over SSL and whether the SSL is correct. We trust this part of the browser to display information which are not spoofable by any attacker. On the other hand, on a smartphone, the attacker is able to have full control over the page and over the real estate because there is not enough rooms, which leave a lot of space to attack, a lot of attack surface to attack mobile phone. I think there is also behind the curtain, there is also a lot of behavior from the phone which makes things even harder for security perspective, like cookies. We know we have session cookies which die when you close your browser. Actually, on the smartphone, we found out that they are not. They are keep between one and the other. For instance, for the Android system, it makes sense because you have the notion of intent, which means that every program can be interrupted by another. So if you want to resume your browsing, you have to keep them. But for a security perspective, it's a nightmare because sessions tend to live longer on a mobile browser than on a regular desktop counterpart. Let me show you a demo to really illustrate this point. We were not the first one to find this out. It was actually, we found a paper which was mentioning exactly the same thing about 2 years ago, and no one actually paid attention to this paper, but we think it's a great paper, and I think you will find the demo very enlightening. So this is the wellsfargo.com mobile website, and in case you wonder, this is a real URL. It's the wf.com. You can go it on your smartphone. It will look like exactly like this. And does anyone knows if this is a fake page, or is it any danger on this one? You have the log, HTTPS, everything is perfect. We don't mess up the demo. Do you think it's safe? Yes, no? No answer. Okay, well, it's not. Why? Any idea? Any idea why when you have the correct lock, when you have the 5 icon, when everything looks perfectly normal on the browser and we didn't crop anything, or we didn't do any pre-manipulation on this page, why is it compromised? It's not the real Chrome. You're right, exactly. And that's something people don't or might not realize is the URL you see on the top is just an image. Yeah, that's exactly what you see on. Yeah, that's pretty scary, right? For those who didn't have hard time to picture it, you can do this, and actually you can use JavaScript to scroll. So basically, the fake URL will appear, so I can actually spoof any website. We choose Wells Fargo. We could have choose Facebook, Twitter, Google, whatever you want. Because basically it's not a real page. And it's really, really scary. Once again, it's because we don't have the Chrome. You can't trust the Chrome. So we can't trust anything on a smartphone. And I feel this is very scary. I don't know if you think so, but that's the phishing problem with it. We try to move to this and try to see what we can do with this more. And we come up with the idea of tapjacking. So for those who wonder what tapjacking means, well, you take an iPhone or you take a smartphone, you add some clickjacking, you shake it very, very hard, and you came up with this, tapjacking, which is basically clickjacking on steroid. So there is one reason why clickjacking is even worse on mobile phone is, first, as we will see, websites don't pay attention to mobile sites, and two, because of the usability feature. So this is a graph we made for a conference about 3 months ago, where we did a study on frame busting defense for website, normal website. And for this conference, we decided to do the same study for mobile website. Can you guess how many websites have a frame busting defense on their mobile site? No. No, you're pessimistic. 2. So yeah, we have 2, which is Facebook and Twitter, and it's because we went to this guy and asked them to actually do it. So that's, It was 0. Yeah, it was 1. I think Facebook had 1 in one of the websites and not on the other one, but yeah, it was close to 0. And actually, for us, it's really scary because it means that you have 2 teams. You have one team which are building the real website, which start to get a grip on what web security is, and they are doing a good job. And you might have a second team which is doing the mobile website and which has absolutely no idea what web security is, and they are doing all the mistakes we have seen in the website and we are fighting so hard to remove, resurfacing, and that's not a good sign. So to prove our point, we made the demo. How many of you are using Twitter? Okay, so for those who use Twitter, you might have noticed that in 2009 there were a huge worm, a clickjacking worm. I don't know if you remember this one, where actually you had link which said do not click here, and people were clicking. And when you were clicking on the link, what happened was they were adding more tweets which said do not click, and it became a huge worm and it almost crashed Twitter and did a lot of harm into the network. For those who don't remember, it was I think in May 2009. So we remade the same demo on the mobile website, and I'm going to show this one to you. So same thing, best game ever, and this time it's really easier for us to do clickjacking because we can zoom on the button, so the tweet is like the entire screen, so no matter where you click, you're going to tweet. And if we go to Twitter, once you're done, take us a little time because the emulator was slow. Here you go. So we were able to actually be able to inject tweets on the behalf of the user in their account. So that's clickjacking on the phone. And it's actually more easy because we don't have to do all the nasty trick like having a CSS to have the button of the invisible div following your mouse. We can just use the zoom function. I have to mention that the Twitter team did a great job. They were very, very active, so they fixed it. So hopefully this one has been will not happen, but we know that there is a lot of other websites. We don't have frame busting defense on their mobile website, and we hope it will be fixed soon. We are a little early, but I think no one will complain if we finish earlier. We just want to tell you, recap a little bit. As odd as it seems at the beginning, you might now believe with us that you can actually attack a lot of protocol by using side channel attack. We show you how to extract the WPA key. We show you how we can attack HTTPS by cache injection, how to break into the same origin policy via framelink attack. We can actually search your inbox if you're using Yahoo, and how to use tapjacking and how scary actually smartphone browsers are right now. And if you like the video of the demo, well, we have a version on it on YouTube. We're going to make them public today. So if you want to rewatch it or want to share with your friend, we're happy to let you do that. And if you have any questions, we'll be happy to take them. Thanks. Yes?
Could you explain the details of the frame tapping or the frame when you were reading, checking for existence of IDs and then frame?
Yeah, sure. So the question was how the framelink attack works in technical. So what happened is when you have 2 frames, one inside the other, one is the outside frame is controlled by the attacker, the inside frame is controlled by the website you want to attack. Bursztein in the Black Hat 2010 shows that you can actually do scrolling So basically, you can read if the